All right, in lesson 5, we're going to talk about absolute value equations and inequalities. So, think back to what does absolute value actually mean? And so the absolute value itself means distance away from 0. So often we say that the absolute value makes the inside of the bars positive. So sometimes students associate, oh, it just makes everything positive, but really we're referring to the fact that it's the distance away from 0 that matters. So an example of this would be the absolute value of 15 is 15 because it's 15 units away from 0. But similarly, absolute value of negative 15 is also 15 because we're also 15 units away from 0. We're just on the other side of it. Okay, so a couple of just quick equations then, just kind of think about. What if I took the absolute value of x and I solved for it by setting it equal to 3? What numbers would satisfy that? Well, the absolute value, if the distance away is 3, that would have to be either positive 3 or negative 3. So in this case, we get 3 or negative 3 as our solution. But what about the other one? The absolute value of x equals negative 3. So you got to think about that for a second. Is there a number that's distance happens to be negative 3 units away? And the answer is no. There's no solution for that type of equation. So already we've kind of learned two sort of shortcuts with this. Okay, so, and looking at these two equations then, we note that the sign on the value determines if the equation actually has a solution or not. In other words, when solving an absolute value equation, once we have the absolute value on one side, the other side determines what we do next. So as far as how we handle this, we want to isolate the expression in the absolute value bars. In other words, make it look like the expression on one side equals the constant. And then here, one of two things is going to happen. So firstly, if the constant is non-negative, which means it is either a positive number or 0, then we split the absolute value into two different equations. Equations without the absolute value bars. Okay, so in other words, we rewrite it in terms of the expression equals the positive constant, and the expression equals the negative constant, and then from there we just solve. So we break it up into two equations and we just solve from there. So the other case that could have happened, or the constant is negative. In which case the answer is no solution. Because the absolute value of any expression can never be equal to a negative value. So it's never possible to have a distance away from 0 that actually ends up being negative. Okay, so an illustration of those two rules. Here we've got the absolute value of 2x minus 3 equals 11. Well, the absolute value is already isolated, so the 11 is a positive number, so we're going to break it up into 2x minus 3 equals positive 11, and 2x minus 3 equals negative 11. So I'm going to break it up into two different equations and solve. So first step, add 3 to both sides. So we get 2x equals 14 for one side, and 2x equals negative 8 for the other. And then I want to divide by 2. And so I end up with x equals 7 and negative 4 as our solutions for that one. In the second equation, we've got the absolute value buried in a lot of other operations. So first step is to clean this up. And I'm going to subtract off 7 from both sides. So 4 times the absolute value of x minus 2 equals negative 4. And then I'm still trying to get that absolute value isolated here. So that's absolute value of x minus 2 equals negative 1. And then I'll look at which case I'm dealing with. Well, obviously, negative 1 is negative. So I've got a situation where we don't have a solution. So there's no solution for that one. Okay, so let's keep solving on these. So I'm going to subtract off the 2 for this one. So 7, absolute value of 3x equals 14. Then I want to divide by 7. So absolute value of 3x equals 2. Now 2 is positive, so I can break it up into two different equations. I'll go 3x equals 2 and 3x equals negative 2. And then, oops, divide by 2. What was I doing? Divide by 3 in both cases. And so the two solutions I get are 2/3 and negative 2/3. Okay, so over here we get 2 absolute value of 3x minus 1. If I subtract off the 7, I get 0. Then I want to divide by 2, and I get 3x minus 1 equals 0. Now, it's a non-negative, so I know there is a solution, but because it equals 0 in this particular case, I don't have to stress too much about a positive-negative component, because positive 0 and negative 0 are both 0. So I can drop the absolute value, set it equal to 0, and then solve. So we get 3x equals 1, so x is 1/3. All right, interval notation represents the set of all numbers between two endpoints. In other words, it allows us to express a range of things. So if we would like to include the endpoint, then we use a bracket symbol. And if we would not want to include the endpoint, then we use a parentheses. And we always write it, depending upon the symbol, from the lowest value to the highest value, sort of a number line order. And we just have to pick the symbol that goes appropriately on there. So let's look at some common interval notations, inequalities, and graphs that are represented by those. So for example, in inequality notation, if I want to graph something that's less than a, that would be a parentheses, and I would shade down. But in interval notation, I end up writing it like this: negative infinity to a, with a being parentheses. So I'm saying start at negative infinity, go all the way up to a, and stop. Don't include a in this mess. X is greater than a, so that's a parentheses shaded above. So here I would start at a and go all the way out to positive infinity. If I include less than or equal to, that's going to change my symbol to a bracket. If I go greater than, that'll be a bracket. Probably should be clear that we're dealing with brackets here. If I want to say it's between two values, so it's a to b, not including those, but it's between them, then I want to put parentheses on both. If I want to include both of them, then I would just simply put brackets on both. Sometimes I want to include one but not the other. So put a parentheses on the one I don't want to include and a bracket on the other. And same with the interval notation. And we can go both directions on that. So A can be included and B can not. What if I want to say that all numbers are part of this? Then I would simply write that as negative infinity to infinity. Now graphically that would just shade in the whole number line. And if I want to say that it's no solution, then I would just put an empty set. Okay, when solving a linear inequality, the only thing we really want to watch out for as far as what makes things different is if we end up dividing or multiplying by a negative. So we only switch the direction the inequality is facing when we multiply or divide by a negative number, or if we need to rearrange the equation. And so just to illustrate that, in this particular equation, negative 4x plus 3 is less than or equal to 27. I want to subtract off 3, which does not justify switching the inequality. It's still less than or equal to, this time 24. However, when I divide by negative 4, that's when I want to change the inequality. And so that would give me a negative 6. So on a number line, I'm at negative 6 with a bracket shaded above. And in interval notation, this would be a bracket from negative 6 out to infinity. Now, the other time when we might want to switch the inequality, not the other time, when we want to. It sounds like it's optional. No, the other time we want to do that is if I need to change directions or change positions where the variable is. So here I've got negative 2 is less than x. If I want to rewrite this so x is on the left side, then I do need to change the direction the inequality is facing. In other words, the first statement says that I want anything that's less than, where negative 2 happens to be less than it, counts as a solution. Or another way to say that is that the solution is anything that's bigger than negative 2. So either way, on a number line, we have a negative 2 with parentheses. I want to shade that way, and so in interval notation, it'd be negative 2 out to infinity. All right, so when solving inequalities with absolute value, we first want to isolate the absolute value expression. So in other words, we want to rewrite it so it says the expression is either greater than a constant or greater than some number or less than some number. And you're probably thinking, what about negatives? Well, we'll address negatives in a little bit. So next we want to identify the sign opposite the absolute value, and that's either going to be a positive or a negative number. Okay, so let's explore what happens when the constant is positive. Let's take something like x is less than, absolute value of x is less than 2. Okay, well, let's kind of think for a second. What kind of numbers would even satisfy something like that? Well, obviously 1 is that, but not just 1, right? It's either positive 1 or negative 1 would satisfy that. 0 obviously would satisfy that. What's the biggest number that would satisfy something like that? Well, 1.9, 1.99, 1.99, right? So when I'm looking at this, the idea that it's less than means I'm looking at anything between 2 and negative 2 that satisfy those two inequalities. Right? So in inequality notation, we would write it as negative 2 is less than x, which is less than 2. In the interval, we'd say it's anything between negative 2 and 2, just not including those. So it's that whole idea of less than. All right, but what about greater than? How do I write it if it happens to be a greater than? Well, what kind of numbers are we talking about here? Obviously, anything bigger than 2. So 2.1 and negative 2.1 would work. So here's 0, by the way, and then we're looking at 2 and negative 2. Something like 3 and negative 3. Right? But it's anything bigger than it. So I'm starting off at one side of 2 going up, and starting at the other side of negative 2 going up. So notice the two graphs are sort of opposites of each other. One they're going in towards each other, and the other one they're going away from each other. So how do I write that inequality form? Well, I'm saying that x has got to be less than negative 2, or x has got to be greater than 2 would satisfy that. So in interval notation, we introduce a new symbol called a union, and we say that it's anything from negative infinity up till negative 2, union 2 out to infinity.